Welcome to Code. Today we are going to solve the problem range frequency queries. Okay, this question was asked in the Leetcode contest. So let's look at the problem statement. It says that we have to design a data structure to find the frequency of a given value in a subarray. So frequency of a value is the number of occurrence of that value in the subarray. Okay, so now let me explain the problem statement. They are saying that we will be given an array. Okay, this is the array, and after that they will give us queries. The queries will have three parameters: left, right, and the value. Okay, so we have to find the frequency of value in the subarray present between this range, the left and the right range. Okay, and it is zero-based indexing. It means that the indexing starts from 0. Okay, so in this example 1 and 2, so elements at the index 1 and 2, the frequency of 4 is only 1. 0 and 11, it means the complete array. You can count the length, and the count of 33 is 1 and 2. Okay, so now the naive approach would be that we would traverse the queries like from left to right, and then we will maintain the count of the elements, like we will maintain the count of the occurrence of that element, and we will return that value. That would be naive approach, and it will cause time limit exceed. So let's see how we can do it in an optimized way. Let's jump to the intuition. So over here I have written down the same array and the queries. Okay, so what we have to do is we have to design an hash map. Okay, and the hash map, what will be the key data type would be integer, and value would be an array list. Why array list? Okay, because in the key we would be storing the elements. Okay, so let's say element 22, and in the array list we will store all the indexes at which the element has occurred, all the indexes. Okay, so let's see how the hash map will be filled and how we are going to solve the queries. So in the hash map here I will mention key and value. So my first key is 12. I will just cancel it out so we can keep a track, and its index is 0. Next key is 33. Its index is 1. Next key is 4. Its index is 2. Next is 56. Its index is 3. Then 22. Index 4. 2. Index 5. 34. Index 6. Now 33. As you can see, 33 is already present. So what we will do is we will add the index over here. 7. 22 already present over here. Now 12 already present. 34 over here, and lastly 56. So in this fashion we will fill our hash map. Okay, so now let's see how the queries will be executed. So our first query is left is 1, our right is 2, and value is 4. Okay, so what we will do is we will get the array list for this particular value. So what is the array list for this particular value? Only 2. Okay, only this is the array list. And on array list there are now two ways. Again here there are two ways. First way is we can traverse the array list in linear time. Okay, and calculate, keep the count of how many indexes lie between this range, left and right. inclusive. Okay, this is the first method. And second method will be applying binary search. Okay, in binary search, what we will do, we will maintain two variables, upper and lower. Okay, upper and lower, and this is also zero based indexing. So what in upper, what we will find is, what is the upper limit? Okay, so 2, which is the element present in the array, this array list, which is closest to 2. And what is its index? We will not get the element, we will get the index of that particular element. Okay, so what will the answer for the upper be? Answer for the upper will be 0, because 2 is closest to 2 and it is present at that particular index. Okay, and let's check for left, 1. So is 1 present? Is 1 or the element lesser than 1 present? No, present. And the formula for the answer will be upper minus lower plus 1. It means 0 minus 0 plus 1, and this is our answer. Okay, so this was the first case. Let's check for the second case. In second case, 0, 11 and 33. So we'll get the hash map for, array list for 33. It contains 1 and 7. Okay. So what is the upper bound? Upper again and lower. So which is the element? Highest element closest to 11. So it is 7. Okay, so its index is 1 and the element closest to 0, because our lower limit is 0, it is 1 and it is present at the index 0. Okay, again we'll apply upper, upper minus lower plus 1, 1 minus 0 plus 1, and that's 2. Okay, so that's the answer. So now let's jump into the code. I will be explaining you the Java solution. Okay, so now this is the hash map which I have created over here. Okay, and in the range frequency we will be given the array, array which we have to divide into sub arrays depending on the frequency. And in this function, what I am doing is I am traversing the complete array, and if that value is not present in the hash map, then I am creating an array list, a key value pair for that element, and if it is present, I am just adding the index in the array list for that element. Okay, as you can see this. In query, okay, in query, first of all, I am getting the array list for that particular value. So this might also be a case that the value is not present. Okay, value is not at all present in our sub array or even our complete array. Okay, in that case, it might be null. Okay, or the indexes, or it might not lie in our particular range. Okay, it might not lie in our particular range. In that case, we will return 0. Okay, otherwise, as I mentioned, upper minus lower plus 1. Right, so this is the lower function. This will take log n time as we are applying binary search, and you guys might know the algorithm for binary search and why its time complexity is log n. Okay, so this is a base case. Okay, and here we are performing our standard binary search operation. If the element at the mid is less than the key means the value, the limit, this is the lower limit, then we will shift our lower left to the mid, otherwise our right will come down to the mid, and in the end we are returning the index of the left. Same goes with the upper here. Instead, we are just reversing this condition and doing this over here, and again we are returning the left over here. So now let's check if this code is working completely fine. So as you can see, this code is working completely fine and it's getting accepted. So if you guys understood what I taught in this video, please like this video, share this with your friends, and even subscribe to my channel for more videos like this. Thank you.